Good morning, good afternoon, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this video. Now, in today's lesson, we are in integration, and basically, we'll be looking at how to find the area under a specific graph. So I'm just going to give you ideas, then you should be able to do these questions by yourselves. So that is, let me just, okay. Okay. So I'll do question 3B, then you should be able to do, question 2, the entire question 2, and question 3A. Okay. So let me give you ideas. All right, so for any graph that you have, say you have a graph like that. So this is the x or y plane, this is the y axis, and this is the x axis. This is the x axis. So now, for you to find the area under a graph, you need to find the boundaries of the y. Okay, you need to find the boundaries of the y and the boundaries of the x. Okay, yeah, so this, let's say this is y1, y2, and x1, x2. Okay, so you need to find the boundaries of the y and the boundaries of the x, and basically what you're going to do is the boundaries with numbers should be outside of the integral. So that is, if there is a boundary that has variables, let's say x, y, or z, they should be inside the integral, and the boundaries with the numbers should be outside the integral. So for instance, if we have x1 and x2 as real numbers, then we're going to have the integrals of x. We start with the lower boundary. The lower boundary is x1, and the upper boundary is x2. Okay, then we come to the boundaries that have variables, let's say x, y, or z. So the lower boundary is the one that is at the bottom here, which is y1, and the upper boundary, which is y2. Then here, since this is y equals to something, so this is maybe y equals to f of x. So meaning that what you're going to have here is the x. So that is simply saying x equals to y, and dy, which is, let me use the color for, okay, so dy, which would be right here. So meaning y is equals to x and x equals to y. So that is the logic there. So here there should be y terms. Then what should be here is the x. Okay, and if x variables, then what should be outside here is y. And basically how you're going to integrate is you start with the inside. Okay, inside, and after finding the integral of the inside, you integrate the outside. Okay, now let's look at the example that I'll do, then you should be able to do the other questions by yourself. All right, so for question B, I'm going to just start with first of all, just a simple sketch of how the boundaries are. So these are the boundaries for the area that we want to find. So we have xy equals to 9. So basically this has asymptotes on x and y axis, something like that. Then x equal to y will be a line from somewhere there going up like that. Then y equals to 0 is, where is y? Y equals to 0 is along this axis. So y equals to 0 is in this axis, and x equal to 9 will be somewhere there. Okay, so we can say maybe somewhere there. So this is where x equal to 9 is. Okay, x equal to 9. So basically we want to find this area. Okay, but when you look at this question, it is very tricky because we have this part here. Okay, so we have this part here, we cannot fully petition, I would say we cannot fully petition the upper boundary and the lower boundary. Then maybe this is y equals to x. Just switch this. So this is y equals to x. We have to have numbers for one of the sides. So basically, if we use, okay, in simple terms, what we would have done is would have said, okay, the lower boundary for x is this one, which is x then to 9, x to 9, okay. Then for y, it would be, the lower boundary would be 0 to this line. So this line, we make y subject of a formula that is y equals to 9 over x, okay. So that is, this line is this one here. Okay, so we make y subject of a formula so that y is equals to 9 over x, 9 over x. Then we say this is for y, so this is dy, then the x outside. Okay, so it will be the x dy. Okay, x dy. So it wouldn't make much sense because outside here we should have an integral with numbers. So what we should do here is we should partition this into two parts. So the first part will be this right here. Let me just so the first part will be this, so this area. So we find this area, then we find this other area, add them as one. So now we need to find this point. So this point basically can be found by solving this equation and this one simultaneously. So to find where they are meeting here. So basically we're going to replace where there is y, we can put x. So if we put x here, this would be x equals to 9. Or basically when we use this one, it would be x squared equals to 9. Okay. And x is equals to plus or minus 3. Okay. So this would be plus 3. Because here, this one is an asymptote. It has two equations. So it will also meet on the other side here. So, but we get the positive one. So we say positive 3. So this one will be positive 3 here. So this is positive 3. Okay. So now we can partition this. So x will start from this point, which is 0, and end at positive 3. Then y will start from this one and end at 0. Then we would have covered our region there. Okay. So now I would say for the x part, so x is starting at 0 and ending at 3. So we're going to have 0 to 3 here outside. Then y is starting at y equals to x. So we put x here. And it is ending at the, oh, this is the upper boundary. So it's starting at 0. Sorry, so it's starting at 0. So the lower boundary will be here, which is 0. And the upper boundary will be this one, which is x. So since this is the x part, so we're going to have dy, then the x. Then we're going to say plus this other part. So this was for this area here. So that was for this area here. Now we need to have this area accounted for as well. So we're going to say x needs to start at this point and end at that point. So that is enclosing these points. So x is starting at 3 and ending at 9. Then y will start at 0. So this will be the lower boundary, 0, and end at, so y equals to that. So this is the upper boundary, which is 9 over x, 9 over x. And basically, since this is a y for y, so this is for y, so it will be dy and the x. Now from here, you just evaluate this integral, which I'll also leave you as a task. So this is a task for you. So try to evaluate this integral. And After evaluating the integral, you can work out the problem here. So this you work out problem 2 here. So the boundaries for x will be the lower boundary is, or let me say for y, the boundary will be 0, and this line here, okay, that is for y. Then for x, again, it will be from 0 all the way to that point. Then you do the same. So here again for x, it will be from this point to that point, and so on and so forth. So work out these problems, and we'll see you in the next video. Also try to work out question 3, then we'll see how we'll move on from there. So have a good rest of the day.